Hello, my name is Sukma Singh, and this is my demonstration for SIT 329 Advanced Embedded System Task 5.0p. In this task, I configure the TC3 hardware timer on the Arduino Nano 33 IoT, and I use it to control an LED and push button. I'll first explain my hardware setup, time configuration, and hard program logic, and then at the end, I'll demonstrate the complete system working. Hardware setup. So for the hardware setup, I'll show you the hardware setup and the images at the end. But for now, I'm just using an Arduino Nano 33 IoD along with one LED that is connected to the digital pin D6 and the digital pin D7, which is connected to a button. And I also use a resistor to connect LED. Uh, and then let's move on to the code. So we firstly have the setup TC3 function. For the timer, I selected T33 and configured it as a 16-bit timer. I use GCLK0 as the clock source, which provides a 48 megahertz clock, and use a divide by 64p scaler. So then we have the TC underscore CTRLA underscore mode underscore count 16 and TCCTRLA underscore prescaler and div 64 with a 48 megahertz clock and a divide by 64 prescaler. The time frequency becomes 750 kilohertz. The time for one timer count is approximately 1.333 microseconds. Therefore, I use 75 timer counts to produce approximately 0.1 milliseconds. So this gives me the basic 0.1 millisecond timers take required for the task. So you can see this. I'll just scroll down slowly. Then we have the wait underscore 0 underscore 1 milliseconds function. This function resets the TCTT counter to 0 and wait until the counter reaches 75. Since 75 corresponds to approximately 0.1 milliseconds, this function provides me 0.1 millisecond delay using the hardware timer. Then we have the wait TC3 of unsigned T. So the way TC3 function using the units of 0.1 milliseconds, it repeatedly calls the 0.1 millisecond timer function according to the value of T. Then, for example, if the T is 5000, the total delay is 5000 multiplied by 0.1 millisecond, which is 500 milliseconds. So then we have the beginning of the loop. Then let's go to the beginning of the loop. This is the beginning of the loop. So for this, the button needs to be sampled at 400 hertz. The period of 400 hertz is like 2.5 milliseconds. This is one timer unit represents 0.1 milliseconds. I need 25 timer units to achieve 25 units to achieve 2.5 milliseconds, and then therefore the program uses wait TC3 before each button reading, giving a 400 hertz polling rate. Then we have the press detection. This is the press detection. To detect an individual button press, I compare the previous button state with the current state. A new press is detected when the previous state is high and the current state becomes low. This means that holding down the button does not continuously change the blink period, only a new press changes the period. Then we have the blink logic. This was the whole code. Yeah. So then we have the blink logic. This is the blink logic. Each button decreases the blink period by 0.25 process. And also for this thing, when the period goes below 0.5 seconds, it reset back to 2 seconds. So therefore the sequence is going to be like 2 seconds, 1.5 seconds, 1.5 seconds, 1.25 seconds, and so on. So then we have this is the LED timing. The program calculates half of the required blink period because the LED has to change state halfway through each complete cycle. When the elapsed timer value reaches the calculated half period, the LED state is toggled. So this changes the LED from on to off or off to on, producing the required blinking period. This was the entire code. I'll just scroll down slowly for you. Yep. This was the whole code. Overall, the program continuously waits for 2.5 milliseconds. Polling interval reads the button checks whether a new press has occurred, updates the blink period if necessary. At the same time, it keeps a track of elapsed time and toggles when the LED when the required half period has been reached. So the program continues this process continuously inside the loop. So this was all for the code. Now in the next this was all for me. And now I'll attach a video in which I'm gonna show you the working of the code. So thank you. So hi everyone. Now I'm just gonna show you my working. So you can see this is the same code. I've just uploaded it and it's uploaded, and we can see right now it's giving us a period of 2 seconds. Okay, and then when I click the button, the time decreases by 0.25 seconds. Then one more, then it's again decreased by 0.25 seconds. Now it's at like 1.5 seconds. Now it's at 1 second. Now 0.75 second. It's now 0.5 seconds. Now when I press this again, it's gonna go back to 2 seconds. Sorry, at 0.5 seconds, then we have to get back to 2 seconds. Yeah. Now we can see it's back to 2 seconds. Yep, that's it. That's the working of this. So, yep, all good. Thank you for watching the video.